continuing on, problem number 1, we have negative 3 cubed. Now, one thing that people tend to misunderstand is that negative symbol. Now, our exponent is only connected to the term in front of it, so we could actually rewrite this as negative 1 times 3 cubed. Now, that would look like negative 1 times 3 times 3 times 3, which is the same as, well, 27. So, negative 1 times 27, I would say that my final answer is negative 27. Let's go ahead and take a look at the next problem. Now, in this case, I have included parentheses. So what that means is that I have negative 3 times negative 3 times negative 3. So here I would have positive 9 times negative 3, which would still give me an answer of negative 27. Now, this becomes very important whenever we have even exponents. So let's continue. Now we have negative 3 to the negative 3 power. So one thing to recall is that we are not allowed negative exponents. So I'm going to go ahead and rewrite this as negative 1 times 3 to the power of negative 3. Now essentially, this is a quote-unquote whole number. So any whole number we can turn into a fraction by putting it over 1. Now, since I am not a fan of negative exponents, I'm going to circle the entire term that has a negative exponent. I'm going to cross it out. Yeah, I said the C word. Because it is negative in my numerator, but if I put it in my denominator, it becomes positive. So let's go ahead and rewrite that as negative 1 over, that would be 1 times 3 cubed, which is the same as, well, 3 cubed. Which, of course, we have already stated is 27. Now, in comparison, I have, again, parentheses. So let's go ahead and take a look at that. That would be negative 3 cubed, so the negative third power. And again, I'm going to put that over 1. So let's go ahead and take this entire term, and we're going to bring it down. So that would be negative 3 to the positive third power. Now, since I have nothing remaining on top here, I could assume that to be a 1. And I still have technically this 1 here. It's not necessary. Negative 3 times negative 3 times negative 3. Which I know to be negative 27. Now, both of these are exactly the same. It doesn't matter whether or not I have my negative on top, bottom, or in the center. It's actually coming out to the exact same number because of the fact that I have an odd exponent. Let's go ahead and continue on with number 5. Now, one thing that I would do is probably use various colors to identify my different parts of my exponential term here. So first I want to identify my coefficients. Now my coefficients are 45 and 5. All I'm simply doing with my coefficients is dividing them. So I'm going to write that a little bit bigger. 45 divided by 5, I already know is 9. Now, 9 is a whole number, so that would be 9 over 1. Okay, let's continue. So now let's look at our x's. I have x to the power of 1, and I have a negative exponent. So I'm going to take this entire term, x to the negative 4, and I'm going to bring it up on top. So let's write x to the power of 1, and now x to the power of positive 4. Okay. And, well, I have my y squared, which is positive, and my y to the power of 6. Now, if I wanted, I could expand this. So that is 1x, and then 1, 2, 3, 4 x's. I have 2 y's. And down here, I have 1, 2, 3, 4, 5, and 6 y's. So we could reduce this set of y over y to 1, as well as this set. Essentially what I have done is I have taken 2 minus 6, which is negative 4. Now because this would give me y to the power of negative 4, I don't like negative exponents. That's why I have 1, 2, 3, 4 exponents in the bottom. I like expanding because I don't have to think, where does this negative go? So let's write out our final answer. That is 9. I have 1, 2, 3, 4, 5 x's. That would be x to the power of 5. And all I have left is 1, 2, 3, 4 y's in my denominator. Now, be very careful of writing your exponents. Make sure that they are smaller and raised towards the top. There we go. Let's go ahead and work on number 6. Number 6, I again have some different parts. So, let's go ahead and begin with the inside. I have my coefficient 3, and I have, let's try another color, b squared. And that's b times b. And I explained to you guys that if you get lost, just expand it out. And of course, I'm raising that to the third power. Now, if you already know your exponential laws, this is the power rule. Now, the power rule says that I take my exponent on the outside and I put it to all factors. So, in other words, that would mean that I would have 3 to the power of 3 times b squared times 3. Now, that should give me 27b to the power of 6. Now, what I want to do is I want to expand that so that I can see this rule for myself. So, whenever something's cubed, that means whatever's on the inside, I'm going to see it 1, 2, 3 times. So that means 3, 3, 3. So 3 times 3 times 3 is 27. And then I have b, 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 b. Now remember, these parentheses simply mean multiplication. So I could have written it as 3 times 3 times 3, and then times b, 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 b. Now, whenever you are multiplying and they have the same base, all you do is add up their exponents, or you could count them out like we did before. That's 2, 4, 6. So we end up with the exact same answer. I can either use the power rule or expand. Expansion would probably be a good idea on example number 7. Now, this is obviously the quotient rule, so I could also say 5 to the power. So let's see this. It would be 5 to the power of 8 minus 6, which would mean 5 to the power of 2, which is 25, or I could expand. So let's see what that would look like expanded out. Ooh, that's a lot of 5s. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6. And as usual, I would go ahead and reduce whatever I could to 1. So 5 over 5, 5 over 5. Leaving me with just 5 times 5 over an implied 1. And 5 times 5 is, of course, 25. So 25 over 1 still gives me 25. And that is the end of page 1 front side.